Imagine a headline not from Earth, but for the cosmos. Humanity reaches for its nearest star. This isn't science fiction, it's the next chapter in our story. We orbit an ordinary star, yet for millennia, we've gazed at the night sky and wondered. Are we alone? The nearest star system, Alpha Centauri, is over 4 light-years away, more than 40 trillion kilometers. If our sun were a grapefruit in New York, Alpha Centauri would be another grapefruit in San Francisco. With today's fastest spacecraft, the journey would take thousands of years. Yet, the urge to explore is in our DNA. Alpha Centauri is our cosmic front porch, the first step on our interstellar map. The challenges are immense, but so are the rewards. Finding another world could change everything. Our story as explorers is just beginning. We've sent robots to Mars, probes to the edge of our solar system, and telescopes that peer back to the dawn of time. Now, our gaze is fixed on the stars beyond our own. Alpha Centauri is not just a destination, it's a symbol of our relentless curiosity. It's the next step in a journey that began when our ancestors first looked up and dreamed. That dream is now taking shape, fueled by science, technology, and an unyielding desire to know. The cosmos is calling, and for the first time, we're learning how to answer.
Why Alpha Centauri? Proximity. It's our next-door neighbor in the vast city of stars. Its light takes just over 4 years to reach us, a cosmic postcard from the recent past. This closeness makes Alpha Centauri a game-changer for astronomers. We can study its stars in greater detail, hunt for planets with more precision. It's the perfect laboratory for testing our theories about star formation and the conditions for life. Alpha Centauri isn't just one star, it's a trio: A, B, and Proxima. 2 are sun-like, the third a dim red dwarf. This diversity lets us study 3 stellar types at once, a cosmic sampler platter. 2 of the stars could host Earth-like planets. Proxima already has planets, including one in its habitable zone. The possibility of finding liquid water is real. Is there a pale blue dot orbiting one of these suns? That question drives us. Alpha Centauri is more than a neighbor, it's a mirror for our hopes of finding life. It's the beacon guiding our search for new worlds. Every radio and TV broadcast from Earth is racing through space at light speed. These signals form an expanding bubble, a faint electronic signature of our civilization. The front edge is now about 100 light-years away, having swept past dozens of star systems, including Alpha Centauri. Our earliest signals reached Alpha Centauri in the 1930s. For nearly a century, our cosmic neighbor has been bathed in the electromagnetic noise of humanity. By the time these signals arrive, they're incredibly faint, almost indistinguishable from background noise. Still, we've been announcing our presence to the cosmos, intentionally or not. Our radio bubble is a silent monument to our existence. What would aliens think, hearing our music, dramas, and conflicts? Our whispers are already out there, traveling among the stars. The universe is listening. Alpha Centauri is a family of 3 stars, bound by gravity in a cosmic dance. Alpha Centauri A and B form a binary pair, orbiting each other every 80 years. Their distance varies from Saturn's to Neptune's orbit around our Sun. Proxima Centauri, the distant cousin, orbits the pair from afar, over 13,000 times the Earth-Sun distance. Right now, Proxima is the closest star to our Sun. Each star has a unique personality. A is a near twin to our Sun, B is a smaller, cooler orange dwarf, and Proxima is a faint red ember. This diversity makes the system a scientific gold mine. It's a natural experiment. How do planets form around binaries? Can life survive stellar flares? The Alpha Centauri system is a cosmic Rosetta Stone, holding clues to the galaxy's diversity. Its story is just beginning. We're only starting to unlock its secrets. The answers could reshape our understanding of the universe. The family next door may hold the key to life beyond Earth. Zoom in on Alpha Centauri A, a near twin to our Sun. It's a G2V-type star, just slightly larger and brighter than our own. If a rocky planet orbits at the right distance, it could have liquid water, a potential cradle for life. The search for planets here is tough. The gravity of its binary companion complicates things. In 2021, astronomers detected a faint signal, Candidate 1, in the habitable zone. It might be a Neptune-sized planet, a dust disk, or just noise. The jury's still out. Even if it's not a planet, a dust disk hints at planetary formation. Future telescopes will keep searching for Earth-sized worlds. Imagine standing on a planet here, 2 suns in the sky, nights never truly dark. Such a discovery would be a scientific and cultural milestone. The hunt for an alpha Earth continues. The next breakthrough could be just around the corner. Now meet Alpha Centauri B, an orange K-dwarf, smaller, cooler, and more active than our Sun. Its habitable zone is closer in, but the star's flares and X-rays pose challenges for life. In 2012, astronomers thought they'd found a planet, Alpha Centauri B, an Earth-mass world orbiting scorchingly close. It was a thrilling discovery, but later analysis revealed it was a false alarm, a ghost in the data. Still, the search continues with hints of other possible planets. Orange dwarfs like B live much longer than our Sun, offering stable conditions for billions of years. If a planet can survive the star's youthful tantrums, it could enjoy a long, peaceful existence. The question, can life endure such radiation? Finding a planet in B's habitable zone would be a natural laboratory for astrobiology. The fiery twin may yet surprise us. Each search, each setback, brings us closer to the truth. Science is persistence, and the next discovery could change everything. The story of Alpha Centauri B is far from over. Now, to Proxima Centauri, the closest star to our Sun, but invisible to the naked eye. It's a tiny dim red dwarf, just 12% the Sun's mass. For years, red dwarfs were ignored in the search for life, too volatile, too faint. But in 2016, astronomers found Proxima B, a rocky planet in the habitable zone. It's at least 1.17 times Earth's mass, orbits every 11 days, and could have the right temperature for liquid water. The planet is likely tidally locked, one side in perpetual day, the other in endless night. A twilight terminator zone might be the best place for life. Since then, hints of two more planets, Proxima C and D, have emerged. Proxima Centauri, once overlooked, is now a prime target for studying life around red dwarfs. Its planetary system is a laboratory in our cosmic backyard. The discoveries here could redefine our place in the universe. The search for life is closer than ever. Proxima's secrets are waiting to be revealed. To truly know Alpha Centauri, we must go there, but rockets would take millennia. Enter Breakthrough Starshot, a plan to send tiny robotic probes to Alpha Centauri at 20% the speed of light. Each Starship probe, attached to an ultralight sail, would be blasted by a powerful Earth-based laser. The pressure of photons would accelerate the probe to over 200 million kilometers per hour. The journey, just over 20 years. Upon arrival, the probes would snap pictures and beam data back to Earth. It would be humanity's first close-up look at another solar system. The challenges are immense, building the world's most powerful laser, creating sails that survive the journey, and designing electronics that last decades in space. But these are engineering problems, not impossibilities. Starshot represents a shift, from slow, heavy rockets to fast, light probes riding beams of light. It's a bold vision that could make us an interstellar species. The first step is within reach. The stars are closer than ever. Our quest for Alpha Centauri's secrets is powered by a new generation of telescopes. The James Webb Space Telescope peers through cosmic dust, analyzing exoplanet atmospheres. While direct imaging is tough, Webb and future missions pave the way for discovery. Enter Ptolemy, a proposed space telescope designed specifically to find planets in Alpha Centauri. Its unique lens will detect the faintest planetary signals in this complex system. We're moving from detecting planets to characterizing them, searching for biosignatures like oxygen and methane. Finding such signs around Alpha Centauri would be a historic breakthrough. Each new telescope brings us closer to answering the question, are we alone? Alpha Centauri is our stepping stone to the stars. The universe is vast, but no longer beyond our reach. Our greatest adventure is just beginning.